about today. So today we're going to talk about isosceles and equilateral triangles. Our EQ is what special relationships exist among the sides and angles of isosceles and equilateral triangles. We're going to prove theorems about, you guessed it, isosceles and equilateral triangles, and apply properties of isosceles and equilateral triangles. Gee, wonder what our key terms are today. Well, they're not isosceles and equilateral because I assume you know those already, but we're going to talk about legs of isosceles triangles, a vertex angle, a base, and base angles. Moving on. Eaton, we're glad you're back. You good to be back? Okay, whatever. All right. Did your wheel sit you back there? Because I thought you were up here now. Whatever. Right. Isosceles triangles, this is what Krosky and I started today with, have at least two congruent sides. Congruent sides are called the legs. The vertex angle is the angle formed by the legs. Right? So here we go. The two congruent sides of an isosceles triangle are called legs. This is called a leg. This is called a leg. The vertex angle is the one formed by the legs. So angle 3 right here is called the vertex angle. Okay? So the isosceles, how do you say it? I-S-O-S-C-E-L-E-S.
Wow.
The side opposite the vertex angle is called the base side.
What two angles that have the base at the side?
And the other two angles that are congruent to each other are called base angles. Okay? You may want to copy this drawing that I've got up here because it's going to be, well, pretty good. Right? So, running through it again. Congruent legs form a vertex angle.
Congruent legs
Form a vertex angle. Opposite the vertex angle
base
is called a base side.
and base angle.
And the two angles that touch the base are called base angles.
I swore he
Alright.
said it right there.
Check it out. A couple things real quick. Isosceles triangle theorem. Two sides of a triangle are congruent. The opposite
Sides.
The opposite sides are congruent?
Opposite.
Yeah, that's right. If the two sides of a triangle are congruent and the opposite, the angles of, why am I reading this wrong? The angles opposite the sides are congruent. Likewise, if two angles of a triangle are congruent and the two sides opposite those angles are congruent. Real quick, y'all, check it out. If I have an isosceles triangle, okay? Isosceles triangle. I go to the opposite angles to get my congruency.
Let's write this down.
No, I just want you to listen.
Do you have a staple?
Okay? Yeah, but not yet. Likewise, if I have two base angles that are congruent, I can go from those angles to the opposite sides, and those legs would be congruent. Okay? So the thing to remember with triangles, because this is going to start popping up over and over again over the next few weeks, months maybe, okay, is that if you want to know about triangle proportionality, there's a big word for you, right?
Proportional.
Triangles are actually, they're in proportion to the angles and the sides that are opposite of each other.
You know, I really hate this class. I really do.
Alright. See if we can work our way through this, okay? I just said something about the angles that are opposite congruent sides in a triangle. What'd I say about it? Those angles are what?
Proportional.
Okay, so they are proportional to the whole triangle, but they are what with each other? They're congruent with each other.
Congruent.
Okay? So the opposite angles down here are congruent to each other.
Two is
Well,
this. Two is. I got chocolate.
Hey,
Alright, so check it out. You got to think about all the things that you know about triangles to work this problem out. The important part would be this. Guys, the angles of a triangle add up to be how many degrees?
180.
Therein lies your answer, okay? you're going to switch from geometry to algebra when you do this. Here's what I mean by saying that. Here is your geometric, well, really, here is your geometric equation. The measure of angle F plus the measure of angle D plus the measure of angle E have to add up. That should be E.
That's so.
Have to add up to be 180 degrees. Okay? If I take out the letters and put in some numbers here, I'm going to have 22 as the measure of angle E. And then if I know that there are two angles that are congruent to each other, just label each of them the same. Label both of them X. Okay?
You could just do 180 minus 22 divided
X.
by 2.
X. 22. Very good. I take my X's and combine them to get 2X. I subtract 22 from both sides of the equation. I get 158. Divide that by 2.
Yeah,
79. Okay?
79.
79. Measure of angle F is 79. Very straightforward. Okay? As a matter of fact, isosceles and equilateral triangles, compared to what we have been doing, they're child's play. Right? Really easy. We'll see how much it is, but we'll see. All right, guys, here we go. Don't even. If you need to write down this word, do it. I tell you what, I'll make this very, very easy for everybody. Write this down. Equilateral means, or is equal to, it means the same thing as equiangular.
What?
Right? I should say it means the same thing as. Equilateral references the sides of a triangle. Equiangular references the angles of a triangle. And let's test our vocab skills here. What do we think the prefix equally means?
Equal.
Very good. Very good. Okay. Thank you, Cameron. Boy, do you? Alright, so make sure you get this part down. That's what these two corollaries mean. If I have an equilateral triangle, then I have an equiangular triangle. If I have an equiangular triangle, then I have an equilateral triangle. Right? Potato, potato. Y'all just got to make that connection in your head. If you have equilateral, it means all the angles have to be 60. Because that's what the next thing should be, is that equiangular triangles are always equal to how many degrees?
600.
Equiangular triangles are always equal to 180 degrees. Let me rephrase the question. The angles of an equilateral triangle always equal what?
60.
So if I wanted to find the value of x here, I would take 2x plus 32 and set it equal to 60. And then you have your two-step equations that you did in 8th grade, 7th grade maybe, right? So take this particular equation, subtract 32 from both sides, divide both sides by 2, x should be 14. So,
where would the 180 come into play?
Well, where would it come into play? The only reason it comes into play, good question, I did this earlier, let me make sure you get it down. This has to be 60, this has to be 60, this has to be 60, because if all the angles are equal, and there's 3 angles in a triangle, 180 divided by 3 is 60. So the only way that 180 comes into play is in that particular
Why couldn't you
problem right there.
do 180?
Well, what you could do is say,
Equal to 180 and
check it out. Here's the, if you want to do the long way, which isn't wrong, it's just way more steps than you need. If this is an equilateral triangle, it's equiangular, right? So that means that if this is 2x plus 32, this angle would be 2x plus 32, and this angle would be 2x plus 32, right? So all 3 of them would be congruent. So you could do this. 2x plus 32 plus 2x plus 32 plus 2x plus 32 equals 180. Do you see how that's way more work than you need? Yeah, my way is probably going to be a little better. But you can't, I mean, we are Burger King. You got it your way. All right?
I just did that, like, you said they're
Arby's, we're not Arby's.
And, you know what I just noticed? That every shape equals 180.
Every what?
Every shape equals 180. Like if you add all the angles, like I did with the square. Maybe not every
No,
shape. but-
not every shape. Actually, it's
I was like a
not that simple.
Oh.
Yeah.
circle's
Just
one.
triangles have a sum of 180. If you want to know, we'll do this later in the year. As a matter of fact, we're going to